Okay, let's start by working with some functions and taking the inverses of them. So remember, inverse is basically to undo. So we need to undo like the plus 1 by subtracting 1, undo the minus 4 by adding 4, undo a cube by taking a cube root. So you can see that all the answers have a cube root in them because we have to undo cubing the function. And then they have different pluses and minuses of 4 and 1 because we're undoing each of these numbers. So the important part here is just to do it in the right order. So with inverses, one way to look at it is that you are basically just switching x and y. So if you want to start off with just replacing f of x with y, right, rewriting the right-hand side as exactly the same, and then just swap x and y. So we're going to make this x equals, right, and make this plus 1 cubed and minus 4, and then this is going to be y. So just swap x and y, and then you solve for y. So if we want to get y by itself, right here, we have to get rid of all this other stuff first, and start on the outside, work your way in. So first we're going to add 4, right? Add 4 to both sides. So we have x plus 4, right? And that's going to equal the y plus 1 cubed. Right, then we'll take the cube root of both sides. There we go. And that's a cube root. Cube root. So that way the cube root and the cube undo each other or cancel each other out. So then we have just the inside left over, y plus 1, with the cube root of x plus 4, cube root, and then subtract 1. So now we have y equals the cube root of x plus 4 minus 1. And then so that's going to be, looks like c. Cube root of x plus 4 minus 1. Number 23, very similar, just we have to find the inverse once again. So this is a square root, so you can see all the answers are squared here, right? And you can probably tell from our what we started with that we had a minus 4 here in our original question on 22 that turned into a plus 4 on the inside of the square root. So everything just kind of switches places and does the opposite thing. From being on the outside and being negative 4, it goes to the inside and becomes positive 4. So you can probably guess here, if we have a negative 2 on the outside here, it's probably become a positive 2 on the inside. It's one way of looking at it. But just to make sure, let's go through and show the actual steps here. So once again, we'll swap x and y. We'll have y plus 5 minus 2. And then do some algebra, add 2 on both sides. So we'll have x plus 2 equals the square root of y plus 5. Right? We're going to square both sides. So we'll have x plus 2 squared. And that equals y plus 5. And then subtract 5 on both sides. So we'll have x plus 2 squared minus 5, and that equals y. So that does look like, yeah, letter A here. It's the only one that really matches. And the reason why we have this domain here, right, is because the square root function, if you remember the graph, kind of looks like this. It's only like half a parabola. So its inverse is going to look like half a parabola as well. It's just going to be from here going to the right. So it's going to be like from x, yeah, at negative 2 and everything bigger than that. So that's why we have this domain here. All right, let's look down here at some exponent problems. So just recall that to solve these, you want to multiply those together. If you have a power to a power, multiply them together. So we'll have 9/5. If you multiply 3/5 times 3, you get 9. If it helps, you can do 3 over 1. Right, so that's a pretty quick problem right there. That'd be C. Which is equivalent to 5x to the 1/2 power. Just remember, 1/2 power is the same as square root. So that's going to be the same as taking the square root of 5x. So that would be B. Okay, 26. Let's go to the second column. Okay, some more exponents. So just like square root was 1/2 power, this is the 7th root. So instead of the 2 here, we have a 7. So it's very similar to the last problem. So we can rewrite the 7th root as the 1/7 power. So this is the same as z to the 1/7. Right? Z to the 3rd, part on the inside, and just changing this part, the 7th root, into the 1/7 power. So just take that part changed into this part, right? And everything else stays the same. So the z to the 3 still stays the same, and this 8 on the outside is still there. Now what we can do is do a little multiplication here as well, and just multiply all these together like we did on the last one. So these are a bunch of power to the power. So we can multiply in any order, really. 3 times 8 is 24, right? And then 24 times 1/7 would be 24 over 7. So write all that out. Basically, I just did this, right? And that equals to 24 over 7. That would be B. Let's go down here. Write the radical in rational exponent form. Now, rational is exponent form is what we've just been doing is writing it with a fraction exponent. Think of rational as fraction exponent. So 1/5 is, fifth root is the same as 1/5 power. That's all they're getting at here, making sure we know that fact. Okay. And let's look at the graph here. Okay. So this is a graph of what? So we have a choice between square roots and cube roots, and it's translated 2 to the left. So we do know that since it's translated 2 to the left, it's going to be an x plus 2. I don't know if it's, regardless of cube root or square root, we know it's x plus 2. So it's not B, not D, right? I'm using this point as my source here. So the question is it square root or cube root? You might remember on that last problem that the square root, right, just looks like that. It doesn't have this negative part because you can't take square roots of negative numbers. Whereas cube roots, you definitely can. You can take a, for instance, square root of -8, and that does equal -2. So you do have a negative side of the function. So this is definitely a cube root, right? All right, let's look at number 29. Going down to the next page. Okay, very similar graph. So we already kind of explained that. That's going to be a cube root because we have a negative part of this. Right? Square root would look just like this, right? It does not have this other half on the bottom. Right? Step function, okay, it just looks like that. And absolute value function is that V-shaped graph. So it's none of those. It's cube root. Number 30. All right, so we have very similar to the previous prior problem is that 1/2 power is the same as square root, but then you can actually take a square root of 4, right? You can take a square root of 4, let's break this up into 2 parts, square root of each part, and then the square root of 4 is 2. So we end up with 2 root x, which is b again. Next, let's do some solving equations. So we need to get this part by itself first. So let's add 15 to both sides. There we go. So we have 4x plus 32 to the 2/3 power. And that's going to equal 49 plus 15 is 64. And now we need to get rid of this 2/3 power. So I'm going to raise it to the 3/2 power, both sides, 3/2 power, right? Because 2/3 times 3/2, that equals 1. The 2's cancel, the 3's cancel. We're left with 4x plus 32 to the 1, which is just 4x plus 32. Over here, we need to do 64 to the 3 over 2 power. So a couple ways of looking at that. So 64 to the 3 over 2. Let's just break this rational exponent apart and make it to 64 to the 1/2 to the 3rd power. So it's kind of like I removed the 3 from the top and just left the 1/2 there. Because 1/2, it means square root. So square root of 64 is just 8. All right. So now I have 8 to the 3rd, which is 8 times 8 times 8. So we got 8 times 8 is 64, times 8 again would be, let's see here, 512. So that equals 512. And now this is just a linear equation we can solve how we normally do by subtracting and dividing. So subtract 32 on both sides. 4 times what equals 512 minus 32, which I believe is 480, and then divide by 4. So here we go. 48 divided by 4 is 12, so 480 divided by 4 would be 120. 12 with a 0. So I get an answer of C here. So practice just this part right here a few times. Make sure you know how to take the 3/2 and just remove the numerator, do the root first, and then cube it. Let's go down, do a few more of these square root problems. Okay, so we're translating a little bit here, which is not, that's important to see, which is not true. Okay, so looking at this graph, it's good to know what each of these values do. Okay, so starting with the translations, we know if it's on the inside, it's going to translate it to the left, right? So left 3 for a plus 3, so we know it cannot be this. The minus 4 on the outside translates it down, so it cannot be this. The 2 in the front, that stretches it vertically. Okay, so that's what that does. So instead of being like this is maybe a regular cube root, this is going to be 2 times the cube root. It stretches it vertically. So that's what this is. So the one that cannot be is stretching it horizontally. Right? If you want to stretch something horizontally, you have to actually have to put a number right here on the inside with the x variable. And we saw that in the trig section an awful lot when we were talking about the period of a function. Let's go here. Actually stop there for this particular video.